If we take the product of two matrices, M and N, and take their inverse, that should be the same as taking the inverse of N and multiplying it by the inverse of M. So if you want to show this, we can multiply the matrix that results from the product between M and N, and then multiplying this by the inverse should give the identity matrix. So therefore, if we have Mn, and then replace a second term with n to the minus 1 by m to the minus 1, assuming that this is the inverse of Mn, and now we can use the associative law for matrix multiplication. So we can take M and multiply that by n to the minus 1, and then multiply by m to the minus 1. And therefore this is the identity matrix, and m to the minus 1 by the identity matrix is the same as m to the minus 1. So what we get is m by m to the minus 1, and the product of a matrix with its inverse is the identity matrix. And we can show why this works with an example. So we have the matrix M and the matrix N, and I encourage you to verify that this is the inverse of M and this matrix is the inverse of N. We're using the previous method that we used for inverting 2 by 2 matrices. And we've also calculated the product of M and N, and then calculated its inverse. So as an exercise, have a go at multiplying the inverse of N by the inverse of M, and you should get this result over here. And post any questions you have in the comments.